Hi, welcome back. We're looking today at the scientific method, and we've got right to the end of our scientific method, going through all the different steps that we would logically go through in order to solve a scientific question and to answer it. And finally, we get to the end where we are testing the hypothesis. And that is, we're looking at that original statement that we made, which we thought could be a possible answer to our question. And we're looking at our results and we're saying, do our results support that hypothesis so we can accept it? Or do those results show that our hypothesis was incorrect and that means we have to reject that hypothesis and start all over again, redesign a new experiment? Does it mean that we're a failure as a scientist? Does it mean that we haven't done science? So let's have a look. Does it really matter if your hypothesis is rejected? Does it mean that the experiment has failed? Have you still done science? Well, absolutely. Let's look at it. If your hypothesis stated something and your investigation shows that what you stated is incorrect, all you've done is prove what something is not instead of what something is, and you most definitely have done science. A rejected hypothesis is not a failure. Be very careful of that. If your teacher asks you in an investigation or in a test, this hypothesis needs to be rejected. What is wrong with this experiment? The fact that the hypothesis is rejected is not what is wrong with the experiment. Not at all. Something being wrong with the experiment, you have to trace back to experimental design. For example, maybe you didn't keep all the variables constant. But certainly a hypothesis that is rejected is not a failure. It simply proved the opposite of what you originally suggested. What scientists then have to do, they've worked all the way through the scientific method, they've got to the end, they've tested their hypothesis. What do they then do with the science that they've done? Well, the important thing about it is that they've got to communicate it to other people. They've got to communicate their answers and their responses to other scientists. They have to share their hypotheses, their conclusions, and what they've found out with other scientists so that other scientists can test their work as well. And the more information that scientists put together, the closer they are to coming towards what we call a scientific theory. A scientific theory doesn't just arise after one scientist does one experiment. Scientific theories arise after doing lots of work, years of work, and all of that work is put together. And then you can arrive at something called a scientific theory. But those theories would not be arrived at or got to without all of those scientists communicating their ideas, their experiments, and what they did. And so writing up a scientific report is vitally important. It is so important that you're able to communicate what you did and how you did it. Remember that it's not only scientists that are going to act on the information that has been presented in a scientific report. For example, you might be a scientist working on a particular chemical in the air that causes pollution. Your scientific report will not only be used by other scientists, but possibly by people in government who need to make new laws regarding pollution. And so scientific reports are out there for the public to use, as well as other scientists. Here's some important terms that you do need to understand the difference between. The first is a fact. That is something that can be confirmed by evidence. I ask you, is it raining? You can go outside and you can say, yes it is because I'm getting wet, or no it isn't. So a fact is something that can be confirmed by evidence and everybody will agree on that fact. I think it's important that you're able to distinguish between a fact and an opinion. Opinions, not everybody will agree on. Remember that. A hypothesis, we've already discussed what the hypothesis is. It's a proposed explanation that still needs to be tested by investigation. We've then got this theory, which is a confirmed hypothesis. It's a widely accepted explanation supported by lots of evidence. And finally, we get to something called a scientific law. A scientific law is a factual statement that explains an action or series of actions, but doesn't always explain why something happens. It is just a law that exists, like the law of gravity, for example. Today we've looked at the scientific method. Next week we're going to look at ways of displaying data and analyzing data. So I hope that you're going to tune in next week. We're going to have a lot of fun. We're drawing graphs. I think it would be a good idea for you to have pen, paper, pencils, rulers ready so that you can actually get a hands-on experience next week.